Hello. Hello. So we're back for diffusion models. Last time, if I remember correctly, we stopped at almost the third part here. Yeah, I think we've done all of this, and we are at flow matching, and we have flow matching. We have some notebooks to check. Okay, beautiful. Now let me just. Is everything fine? I hope so. Yep. Next. UV, PN. I don't need any of this, I guess. Am I right? Am I right? Am I right? And I did that as well. That's just the initialization. UV instead UV add a notebook. Same thing. Okay. Hey. CTC. We are too late now. And what else? I had before the stream, 24. That's Sage. Okay. UV. What is it? Yeah. Fish. Oh shit, that's a huge install. That's a big fat install. Oh. Hey محمد بابو، ça va? Comment ça va؟ كيف حالك لاباس؟ كي مروح؟ يا كل شي تمام، يا كل أمور كانت بخير. احنا اليوم بنعدلوا اسمه قاع فلو ماتشنج نكمل نكتب لكم فلو ماتشنج. عندي ونتي امبلمنتاسيون نعدلها ما زلت راهي تحت وقف فيها ونباسي شور ان شاء الله شور انجراد يورا اوكي صر صحة ما شاء الله. لباس شي بخير عندي قاعد كاملة تمام. الحمد لله. ايه باطن احنا اليوم عندي هذا كور لين عدد تديهو كونتينيتو تديهو انتو اليوم فيه باسي شور اقابل الكور راعي عن فلو ماتشنج انت كان اكمل هذا اي اي ولا شي فلو ماتشنج متودس المانك من هذا اي فلو ماتشنج الجوريثم دي يشغل دائما في جنريشن للصور فيديوهات. first time here مرحبا سبسكرايب to the channel. لحقت مالي شي 300 ابون سبسكريبشن كانت 303 جاي من سيرفر والله. نو مانيش جاي من سيرفر تعود اسمه انا جاي من جروب ريمي اي كوميونيتي اي اي جو بونس. أريد لي يعطيك الصحة. No model named what? يوصل مرحبا بيك. Has multiple distributions. What do you mean? Ah. أحمد طريقة يفكس بيها حد قضية. let me just do something. The end. What that I can run. كذلك في قبيله disk what is it again okay face okay جيب كامل عملي داجيهم يقول راني فيكسي environment كان لانسو هذا التريك يشتغل مرة واحدة. هذا عايد باش مازال اللي قاعد انا مازال لي شوي كيستيونات ونت اياها سابق بارتي 3 وي انا وقفت اكزاكتومون هون ندير من كيستيونات اللي جاوبتهم. هذا ماي انسر هذا جاوبت هذا وهذا مازال ما جاوبت هذا الكيستيون دونك سابقين نورمالمون على جاوبتهم كاملين يا و applying party 3 transforming distributions with STs. هذا مازال بارتي 2 اكسبيرمنتي مع STs اللي stochastic differential linear dynamics. سبحان الله شفت نهار العيد في توك على يوتيوب اسمه مازال باطاي بارتي. هذا كامل المسائل يعني experiments ب STs من الاساينمنت الاولى. فاذا I guess صارت يلا يشتغل. يعني صرتي بحال هذا ça doit marcher. Flow matching. Yep. Is that okay? That's okay. And here simply let's change it to live streaming. And that should go. Yeah, that should be fine. Now if I search the thing, it should work. And if I import NumPy, it should work. Like that. And if I buy notebook it should work. يعطيك ماجن راسك مرة لازم تعدل. يب good boy. اوكي جميل. هذا اللي يراني حد يراني ولا يكثر الاخبار. شوف انا ميتري كذا كان هم c'est bon. Shouldn't you been using ChatGPT for this kind of configuration? Well, true. But, you know, I just have the habit of doing it manually. Maybe it's wiser to do it with efficient. No, I think يعني إني قاعد أحاني ChatGPT عدد. Maybe it's it. بالنسبة لذلك هذا اختيار دي particularly كنا كذا اختيار. أنا كنت لان كوبي تو كونفيغراسيون من بلد شرب بلد ثاني. اوكي Hey, Bashar, ça va? Moi aussi. Welcome to the stream, man. So today we are continuing our journey with flow matching. نكونتيني لي زيكزارسيس وما يقدر حد يراني هذا كامل بلاصة. It's cool actually doing it manually. Okay. Well, as long as we are okay, restart and run ourselves. بس في صعب. بس. اوكي يعطيك تراني هذا. اوكي هاي سيميليشن، هاي اللي تفوت شوي من الوقت هيك تشتغل. اكواهم اكران شيت النمبرز. شو هو بيكو I was expecting حسين ما رجع. اللي كان معي المرة الماضية كان اوكي كول سوبر كول. جوشن لما لحقنا دونك اوكي ما قال حق ذاك ومازال بتفرق معها مناش وقتها هون سيبون جينيريها وقتها هاي سيميلاسيون. اوكي نحن المرة الماضية مازال اي question ما عرفنا عنصرين. What conclusion can we draw from the figure above? One qualitative sentence is fine. We'll revisit this in section 3.2. اوكي اذا بتذكر عن اللي نجبر ياسم من figures واللي هي تم هو اللي شانش هون تياها ويقبل هون تياها تي اللي اسمها ايكارتيب هو اللي هي فيكسي واللي هي يتم يفارقي اللي هي يتم يفارقي سيجما سي هما ديكارتيب هما هذه كرانتي نو سيجما صغير واللي هي ديهات هما هي فيكسي ديهات وفيكسي سيجماهات يتم يفارقي تيتاهات تيتا اللي تساتسفاي not true c'est pas vrai هو ديجا اللي انت تقبل سيجما ودي ديجا تقتيري منهم تيتا بلا فورمة دي تساوي سيجما كاري سي 2 تيتا. بالنسبة ماريمو قدي سيبورتي واسمه دوز ماريمو سيبورتس ايبا ان بي بيهلي شكل زين يعني هذا قد سيبورتي ايبا ان بي تلما زينة. يو this does handling of API and B. So how can I install Mario? That's actually that's cool. That's super cool. With pip install Marimo notebook at next generation Python notebook. something more modern من هذا شوي وقت يا جوبيتر. فيها it looks nicer etc. So let's try it. And I'm sick of this UV pip install Marimo. قال لي عاملين انستاري ستريك not good dependencies. That's it. شوف شغله على الماوس جي not bad 8 ميجا بايت not bad not really bad. Okay UV مريمو يلا يعطيك اختيار منه والله. Good to know, thank you. صح. That's I'm glad. I'm super glad. Bye. مريمو. By X. Pipex. مريمو. أنا ماني قاعد هو اسمه environment. مريمو يعطي اشتراك تاع واحد. اوكي مريمو تباسي له edit نسبة edit invalid. اوكي ولا بدأت convert tab 1 اوكي شو قاعد tab 1 تتبايش نكتب سل اوكي pas mal quand même, pas mal. Retourne les trucs, d'accord. انا بديكم انا عندي تورش بقى ما يجيش على راسك تمام تكفر. مريمو اديت وين دت يلا يفتح لي براوزر نسبة. نايس I like this. okay looking good. مسك عندك زومي. take over. يا شت الديفيرانس. هاد مداري هذا النوت بوك يلا هو زين خير يعني تخطى زمنه يا ناس. ديما 2600 تعدون ستايلات ديزاين ديما ديس والله راح انت مريمو شكله صار زين. كون أنا يرني لوكال أنا كنت خايف منه. أنا كنت سامع بيه أصلا كنت خايف عنه عود ما يرني لوكال. أنا يرني على ريموت بس. أوكي جود. أنا كنت قد رني هذا كان الحق قد مشي له عنه يرني. لا كواشت إبرتامارينا كواشت زين هذيك الوقات تنقل. أوكي looking good ما تمولي كيا ماش syntax واضح شوي. missing packages install with pip package manager what package manager خالك حتى هذا هو اسمه. هاك الشي مريمو يقبل من ماركاي. يا وي كاغل اونلاين. انا كنت فاتح هذا في كولاب يقل فهمتني. هناك عندي شي اوفلاين اكسبيرمنت انا معه ابري ومري مريمو ابارامات كونفرتسي بيناتهم ان شاء الله يعد كونفرسيون ما هي اخبارها ما يسبق. باكاج مانجر اوتست باكاج مانجر اور مريمو to be دقيقة. جسبير عن هذا شت قل. وي هون ايرور. تريس باك سيجما نيم سيجما. وي ذاك apparemment ما هو exactement. يا عدل لي ذاك وردح لي بان في مي ديفينيسيون شوي هون مريما. نيم سيجما is not defined. do you mean underscore sigma؟ حق الله شوفوا هذا شنو. name underscore sigma not defined. do you mean underscore sigma؟ bro they are the same. why do I need it's not looking good. It's really not looking good. Okay. Run yo. Okay. ذاك هو البيئة مشكلته كانت من هذا. مشكلة كانت من إيداع فرما. مشكلة جاية من هذا الوقت وي في ذاك واحد فاهم معاه. نايس. good. That is looking good. Stuff is looking good. مثل I can get show command palette. Look at view. Okay, shit, that's not what I want. Okay, I see. عنده فيه عايد من دون okay. لا أنا محمد روسي ونسيها أريد أشوف وزاد Excuse me, what the fuck bro? Okay, monitor. أصلا كنت كاملي تودو تايت وأنا بستويت أهو. What is this joke? ايوه attends ça mais j'étais comme vous laissez passer time steps okay you're playing like that في واحدين ما هم مكملين ديك حالتهم kind of a sick shock is this TS مالي ما عنده مشكلة TS ويني حرفيا دريهي باتيكونا اوكي d'accord يشتغل شويست مولي d'accord ده بوكي تكلم خامر اوكي c'est bon ça marche okay the next ones should work right اوكي هو ماشي يرى كاملين الله مستحفين شو اوكي ذاك كويس طلع عنده مشكلة apparemment اوكي c'est bon with full that's nice شبه انه with full medium or set d'accord مريم ما رحبت بينا ترحيب صالح what is this bug now bug unexpected T0 X0 okay ما يقولوا لك حد هذا وليك الوقت تذكر عنه اوكي كول كتير قدام شابو probably عندك كشتان we have some clear mathematics not so much really where is the other one أنا قلت أعدلكم دارك مود وفي مالي دارك مود هذا user settings display lights dark yeah بعدين بدنا إعرابي that's fine okay, cool. هاك مازال يشتغل. كذلك أنا متابعة KC بداية No, doesn't save the data. Okay. One minute. Yeah. Anyways. هنا تعريف فيكسي سيجما اللي هي اتيتيدد behavior simulations the brownian motion ما هو brownian motion exactement yeah I guess عنده brownian no بس هو brownian عندنا أكثر brownian motion لكن عندنا something else عندنا Orstein Olympic process. Okay, Orstein Olympic process is this stochastic process. عندنا drift minus theta xt. لا عندنا أصلا عندنا لا system dynamic attractor. يقال مزيد عليه diffusion. do the diffusion random factor من brownian motion. Okay, some volatility صغيرة. Okay, that's what they call it in the business. Okay, okay. You had the first question was lateral tiltcare. Typically, the trajectory of xt look like for a very small value of theta. And what about a very large value of theta? Theta هي تمثل هنا سياحة حكم انك شيء attractive للسيستم شور زر كبير ينسل السيستم اللي تجبر عنه xt من يعد مهمة هذا diffusion يعود solution system xt عنه exponential moins theta t d'accord exponential moins theta t avec le temps اللي هي واحد زيرو ماشي تكون شي واحد زيرو حتى طبعا بوزيتيف نورمال هنا تيتا ايجاس انا بوزيتيف تيتا صغيرة اللي تسوي ذاك الكونفرجنس تو تيتا كبيرة اللي هي سبيد ابي اللي سبيدي كونفرجنس تشوف فرتيتا سمال يلا يعود هو أنا قلت فنتي المرة الماضية عنه اللي هي رسمي للبرون ماشي بيدي عاد هذا كتير لا هو برون ماشي عاد هذا ترى من يكون عاد صغير يا خير يعد هذا بالسيف يعدل الإفكت أوكي قاعد يقول إكسبونسيال دونك يلا ذاك الدور ريكومبانسي بالعجلة وبورتي تصارج دور هذا إكس يكونفرج بالعجلة شهر زيرو وإفكت براون ماشين يعود ما هو كوال حتى خل فهمت إياها خل هذا ما هو كوال هذا لا توف يعني هيرستيك ما هو من قام هيرستيك لا شو تسمى تويشن and so the SDE solution will converge to an ODE solution هذا اللي قلت عنه المرة الماضية and I'm not sure about it يرجع في the drift and diffusion coefficient of the OU Olympic Ornstein Olympic process class below في المرة الماضية this is fine this is completely fine and this is the simulation code عندنا theta and sigmas for first thing and theta and sigmas هنا for these theta and sigmas process بنفسه اللي هو يعطي deterministic اللي هو عقب ذاك كمان يستعمل فيها diffusion process عقب ذاك that's the diffusion process. diffusion بعد هو اسمه factor ترى وذاك شتي يعني أشوتي هذا اللي بربيلي فهمتيها إذا باش عاد diffusion كذا باش عاد هو قرب يدوم يعني يزيد volatility يقولون وتو هذا الاثنين هذا كاملين عندهم fixed data fixed drift d'accord so وإيش same هنا تياها عندنا wait a minute this is the same simulation or what يعني عندنا بالنسبة للأول عندنا some هذا عدد trajectories to يزيدون بالنسبة the first time we have 10 trajectories and I guess the other time we have 500 multiplié par 50 donc this is a beautiful distribution اللي تمشي له pendant ça وهذا كتير يمشي واحد شيء كنورمال distribution هذا بربي شيء كم ساعة it's not just any what he said it's not just any Brownian motion it's this thing because yeah the Brownian motion is this crazy thing see so that's something يعطيك فاهم يعطيك normal distribution okay this what did you notice about the convergence of solution? Are they convergent to a particular point or to a distribution? Your answer should be two qualitative sentences in the form one theta or sigma for up and down, up or down. We see. Take close attention to. Yeah. هم ماشي معدينا اسمه normal distribution في حالة sigma in the case where sigma is positive. If sigma is not positive, if sigma is 0, then it's gonna be just the deterministic flow. Okay, and if sigma is positive, it's non-zero, then we will get a normal distribution with centered normal distribution with the negative of sigma square over 2 theta. I should do this proof sometime. I'll do it. I'll try to do it as soon as possible. Okay, about this one. This is the interesting part. Now we are fixing sigmas and these and standard deviation of the final distribution. Okay, which is sigma square over 2 theta. Okay. My shit. Okay, so I have this thing is flickering for some reason. I have okay, now we have sigmas and we have these, and we are simulating with a time 15 and can I do here? Use this simulation time and number of trajectories. 15 and a fixed number of trajectories, and we are plotting for each d and sigma, calculating theta simulating the process. Yeah, so I think this one shows that when the convergence happens and how, yeah, it shows. For example, for this one with a fixed t, the t determines when the convergence happens. Okay, this one has a t of 0.25, and this one has a t of 1, and this one has a t of 4. Okay, so this one we gotta cut real quick with theta being 8, and yeah, so what we understand from this that yeah, what affects the shape of the trajectories is just the t actually, not the sigma and the theta. Okay, these are, all of these are almost the same. Oh no, they're not the same. They're not the same. We have here this shape is the same, is determined by t, but you see this one converges. Yeah, this one converges really quickly, and this is quicker, and this is much quicker, because you see the time here. Yeah, so that's the story here. So theta, not theta. Okay, wait a minute. Yeah, so theta or sigma, sigma controls the speed of the convergence. Yeah, because you see this shape is these are the same shape, but they happen. This one is slower than this this and is slower than this. So the bigger the theta is the sigma, the faster the convergence. Yeah. Of course. The bigger the theta, the faster the convergence with a fixed t. The fixed t, the bigger. Speed conversion. Is the bigger the sigma. Okay, this is the thing. Okay, now let's go to the third part. transforming distributions with STs. In the previous section, we observed how individual points transformed by an ST. Ultimately, we are interested in understanding how distributions are transformed with an ST or an ODE. After all, our goal is to design ODEs and STs that which transform a noisy distribution, such as a Gaussian, to the data distribution P data of interest. In this section, we will visualize how distributions are transformed by a very practical family of STs, Langevin dynamics. First, let's define some distribution to play around with. In practice, there are two quantities one might hope a distribution to have. The first quantity, two qualities, one might hope a distribution to have. The first quality is that one can measure the density of the distribution. This ensures that we can compute the gradient log px of the log density. It's just meaning that the measure, the probability measure is absolutely continuous or something. Maybe that the probability measure has a density. That's what he's trying to say. I don't know. This quantity is known as, I can check with the AI. This quantity, I'm gonna check. This quantity is known as the score of P. It paints a picture of the local geometry of the distribution. Using the score, we will construct and simulate the Langevin dynamics, a family of STs which drive samples towards a distribution pi. Okay. In particular, the Langevin dynamics preserves the distribution P. In lecture 2, we will make this notion of driving some more precise. Okay. Okay. The second quality is that we can draw samples from the distribution Px. For simple toy distributions such as Gaussians and simple mixture models, it is often true that both qualities are satisfied. For more complex choices of P, such as distributions of our images, we can sample but we cannot measure the density. In these notes, we will emphasize distribution as first-class objects that we will sample from. We emphasize that in practice, this is cumbersome and one will instead opt for e.g. torch, rod, and perseverance. Okay, here, d'accord. This is an abstract retractable density, d'accord, underscore, just squeeze this tensor and okay, make it one-dimensional and squeeze. Okay, Jacobian of the log density. D'accord, of x. What is vmap? It's vectorizing map that returns a new function. Systematically vmap pushes the map into PyTorch version called by effectively vectorizing these operations. Okay. Okay, so that company are moving from pure transformer to as Mamba. Transformer plus MOE to so then these concepts. Okay, yeah. I saw, but yeah, yeah. Actually, the course last night we will implement MOE, but I think Mamba is not it cannot be used with MOEs. Mamba is a different architecture. I think it's a different. Yeah, it's a completely different architecture. I've not studied it yet, but I saw some paper on it, or I saw it somewhere. Yeah, it's used by these guys. It seems to replace. Yeah, it's being linear though. That's a huge one. Check it out first. Yeah, surely. I'll check them out. But yeah. But I sensed that. I did sense that. Uh, and a good thing though, as I said, at the course of Stanford, that elements from that language models from Scratch. That includes MOEs, includes the Institute of Experts. Yeah, it has the MOEs implementation. Here, I guess, where is it? It's yeah, it's I guess it's on the second. I saw it here though. They included in lecture 4. So we will probably touch on alternatives. Hopefully we implement it. Hopefully, I hope so. I hope we do implement them. But thanks for the cited info. For sure. Thanks, man. Thanks, buddy. Okay, company are fucked by villains. Yeah. So what should I do here? Yeah, I was thinking, what is this? Let me check with the. Dissect this. Dissect this. What is it? Okay, sure. No matter the compute priority density in probabilistic models, whatever. Okay, like that's the first mode. Okay. ايش فانك ايش كنت mm-hmm. Okay, this thing should do what exactly? Log density. It's just calculating the logarithm of what? Yeah, it's passing this function that calculates the logarithm of density. Okay, and yeah, okay, okay. Takes f and returns a function that computes its Jacobian using reverse. Okay, returns a function that computes its Jacobian using reverse mathematical differentiation. Okay. Okay, sure. 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 Okay, gradient vector. It's a function though. Okay, this is on the Jacobian at x. So why don't we just pass it to it directly? What do we need if we map? Returns a function g, takes a function f. There's a function that operates on batch over batched. Ah, okay, sure. Okay, so this is for batched inputs. Okay, no problem. Got it. Score and squeeze 1, 2, 3. Squeeze 1, 2, 3. What the hell? Why? Okay. What does this mean? What's this? Remove dimensions. I think this is 1, 3 only have one. D'accord. Have a couple of research friends. Their goal is to try building up different architecture that not some entirely shifting out, not some to receive vision from 30, 20, 30. Oh, it's ambitious. It's ambitious. Yeah, Transformer is so dominating nowadays. Well, I mean, to be my humble take on this, I'm not at all doing research now, or even at that level, for that matter. But you cannot have, you are limited by, you'll be limited by just treating sequences. Okay, you cannot know the world by sequences. You should have something like, I mean, I'm trying to say that what Yonder Khan is saying is that you cannot really have the best intelligence with just sequences. the actual AGI with just sequences. You need to have some kind of understanding of the world, or some, because sequences are restricting, so much restricting. See what I mean? Is a restriction, is a limiting factor to be able to understand, for the model to be able to have a representation of the actual world, whatever that means. Jan LeCun is saying the same thing. However, yeah, I'm not sure even if he's what he's doing gonna cut it. Squeeze, remove a single dimension at that index. Okay. All dimension of size 1. Contextual ontological recursive engine. Fancy name. Fancy name, I would say. But core. Core. Recursive though. Why should it be recursive? Because, well, I mean, I shouldn't be critiquing for just the sake of critique. I'm just saying that there is nothing like progress is made by doing steps, whatever they are, or whatever the step is. And these are very interesting steps. And however, achieving the actual AGI should require, I don't know what it should require. No one knows. If I say I know, I'm definitely lying. But this is all this is done. It's done incrementally. Normally, it's done. At some point, this will help unlock the next model or the next architecture or yeah. But we are my personal opinion is that we are nowhere. We don't have yet the actual best architecture for modeling general intelligence, whatever that means. Anyways, I don't want to sound like a broken record, but just continue. What is this? Adds a batch dimension. Adds a batch dimension, and they're trying to have artificial brains. I got humbled when I listened to them. Yeah, that's super interesting. this podcast adds a batch dimension, compute scores. Excuse me, sir. That removes the padding, dims to recover the original shape. Oh. Oh shit. Okay. What? I need some. Let me try this code. 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 Each. Okay. Let's squeeze. And squeeze. Broadcast and touch. Touch. Okay, let's see if the AI can teach us stuff. Yo. This was the intended solution. Say there's a project can check it. Yeah, also iterating 12 times to get to the same state, or iterate 11 times to get the state before it, i.e. the inversion. Yeah, true. Also seen someone, which was one of my idea. True enough. I don't think 3 was enough. I don't think 3 was enough though. 2-3 years will be leaving the company, willing to farm, to anchor children. Get on the language. Huh? It's on YouTube, man. I should then again my streams.
Yo, Aziz.
Craft طبعا مسك لي يستدعى حد على الستريم يكيت لك في اسمك سامعني هذا يعني
So, how is diffusion?
Yeah, that was back man. Just to get to it here for
Okay.
pardon.
والله مستني ذكرنا تلعب.
لا سيبو، انا عندي نسيان دون فيريفي اللي تالي قلت.
اوكي اللي قالوا فولو بتاعك.
يس.
عندي قاعد تليفوني مش
Can't handle this big brain person. Which big brain are you talking about? So stock. Like the company or what?
is
ما يشتغلش.
ما صلح لا.
لا
ما
تروح
تستفيد،
لا
لا
تروح ما يكافي.
انا شفت ما تستفيد، شفت من السوليوشن اللي من مطرح ذاكرتها. انا شو مشي كود مشي لك كود ومشت انا يدستي مولي.
No, down to 12.
I send it in the chat the group of voice chat
Okay.
اللي فيه نحن قاعد.
ده يشتغل يا اخي لا تروح ما يشتغل فهمتني.
ده يشتغل.
دوز يشتغل دوز به هو بي بي سي ام هو الكبر هو صغر من التيب المشترك بين كات و 2 و 3 باردون ما كات و 2 3 بين 3 و 3 هي التالية يسبقها 2 يسبقها كات. كات هي الأولى ياك 4 اوبراسيونات تلبتين ياك ترجع بالملي كنت السطر الأولى، اوبراسيونات 200 ياك ترجع بالملي كنت السطر الثاني، وثلاثة للتالية. كل اوبراسيون تعدل هياك يعودوا كاملين يرجعوا بالملي كانوا. هو اصغر من التيب المشترك. علاش اصغر من التيب المشترك؟ صح بيه اللي نتقبل من التيب من التيب باغ اكزامبل نتقبل من التيب من 3 يسوى شنو اللي تم لا ترجع بالملي كنت بالثالث. فهمت؟ تقابل دوز من ستيبل من 3 دونك يتعد لك 3 4 مرات بالتالي ترجع لك بالملي كنت اللي تم لا ساكنه.
يس I get the idea. انا قناتني شنو قالوا اونز نفس الشيء دوز يعني ياك ترجع لنفس
Exactly.
كما جربت
3 ما صح؟
مشيت
3 صلحت لك
طلعت لي نور
ذاك وات ذا هيل شو when it kind of pushing me to build pushing my brain I did say Mr. Funny pushing my brain to build up new brain for my brain going to be hurt to burst. Well you're working on AI or on I think you're working on both. That's my understanding. Okay, this is no, it didn't work. Shift.
just copy paste the code.
أنا copy paste to the trick.
ديريكت فين قالوا جاتني بعد فلاج ديريكت يعني.
إيه يا خير ما فهمتني. التروا ما تصح. wait a minute هاي شوي.
يس ترى هذا تو اوبريشنز لايك ديفلوب فلاج يس غلط التستي لا كانوا شغال نفس الشيء.
هو بعد ما ينفع يرسل ذي الأولى. إيش هو؟ يعني كان فلاج بعد هو اسمه هذا خطأ. عندي قاعد واسمي وصل سي use for example use هذا من انه خاسر.
زيرو
اوكي يا اوكي اوكي
أونز كان
اونز
يعني
اونز هي حين شوي.
نحن قبيل توصلنا للرواية على ندوز بالفعل ترجع نفس الستيت. أونز ستيت السابقة فاهم كنا انفرت.
طبعا صحيح. اكزاكتومون
أونز هي الانفرت. أنت لازم تروح تمشي الانفرت.
اكزاكتومون
So,
غير pourquoi تروا هي مودي زاد هي انفرس.
ثروة ميبي ثروة تصلح بالتالي أنا متذكر بيننا صلحت فيها ما أعرف نفرفيت معك التماصيل.
وي عندينها بيها عن هذا كاب بارتيكولير الستيت والله ما تصح ماني شاكة بيه. anyways this is an interesting subject دون نشعر بالكين
Yes, interesting. أول شو ما ستيشن قالوا لايف يعني ديفيوجن.
هذا هو وانا نتبارك معه اني كنت ندور نقرا شيء بايتورش عنده ميثودات ونتيا سكويز ان سكويز they have this squeeze and squeeze broadcasting thing. بايتورش تمانيبيلي تنسور جنراليزاسيون لماتريس لكن ماتريس 2 dimension فيكتور 1 dimension عندك ليست واحدة عن اتجاه واحد في ماتريس اتجاهي تنسور اللي تعود تزيد عليه اتجاهات أخرى.
اوكي
yes دور كانوا نشوف نتيها skill ينقالها teach
نايس.
شوفي كانت تنفعك على شيء أعطيه الكلوب بس with high efforts. stuff. Okay.
Interesting UI cloud. What is this?
Huh?
The UI cloud. ما UI cloud normal.
Go back.
Okay. Yes. مش عاجبني والله.
Yeah, it's brand new. What is it? Decision. I know indexing basic apps. It's me up practice. I can okay. Okay. بتشك وارجع من yeah AI but for researchers you know the company I think you have watched my company videos on YouTube also. No, I haven't I think I've checked your account once. It contains some stuff about trading or something, or it was empty. Yeah, your channel is empty. اوكي كول شوف كان برود كي تقريني الرواية بوشتر دون نرجع لأبري فهمت البرينسيب ان جنرال اللي غير نفتر نتعامل مع هذه سكويز ونفهم اللي وشو وعندهم الرواية يقول برودكاستينج شفتوا نتي هذا اكزامبل يا غير it's a bit crazy. Okay, sampleable something that implements sample number of samples and it returns a tensor. Okay. And we have this function, several plotting utility functions. This is more for cont. Yeah, I guess so. Why do you call it stock mantra tips? It looked like you had a plan on creating some content and you didn't. Some tips for the traders, or I don't know. So plotting utility functions. Okay, this is for stuff. Same old mistakes also, same old stupid mistakes. I think this should work. This should freak out. It will freak out later. It will. It will because it will. Sampleable is fine. Number of samples is fine. X is the one that is not fine. Should be fine now. Should be fine now. Should be fine here. Should be fine here. Am I right? I think I'm right. That sounds good. And what is this? Not for randomness. If company find out, it void my contract. What do you mean? Kind of they don't allow you to what exactly? So you're can't use YouTube? You're not in a place where you can use YouTube? Is the density and sampleable? Wrap around yeah, multivariate normal. Okay. We have the mean, we have the covariance. Okay, the mean is two-dimensional. This is yeah, what is that supposed to mean? What is that supposed to mean? Yeah, a pair, I guess. And this is square matrices, matrix, which is the covariance. This is a two-dimensional vector, and this is a square matrix. Okay. We have a property called distribution, which is calculated this way. جاي تعيد عنك. D'accord. D'accord, Qt browser. Okay. شو كور دراي. Claudio. See. طبعا لو يقصد كثر multiply per sample scalar by per sample vector. Many comparative infrastructure knowledges to many YouTube lives. Damn. Well, so share with me. Share with me. Share with me more. Give me more of that juicy tea. I know schedule alpha t. Okay, times data z at time t time velocity field. These vectors have different shapes yet. Alpha times z. Okay, numbers is fine. There is broadcasting, and it's not magic. It follows exactly 3 rules: right to left. Okay, broadcasting right to left. he should give to vector. Broadcasting right to left, right is just, I believe in the concept of knowledge should be free to everyone. Yeah, same. That's true. Broadcasting right justifies broadcasting right justifies the two shapes. Then stretches right justifies the two shapes. Okay. Then stretches any axis so size is 1 to match its partner. Then to align shapes from right, and you can predict every shape before you can code. Okay. Realize the two shapes, let them flush on the right. Align right, parallel. If one shape is shorter and one until match. Matches every pair. Instead of doing this HTML thing, just do exercises in Python files. You go from simple general to this progressively more advanced. Make them in a way, make it realistic. Like things for these concepts. Like, it's oh shit. almost dying. I want to change the model. I want to change the model. Anyways, I think we get the idea. Distribution. Oh, distribution. Okay. This is the big B that is here. Validate normal distribution with the mean with that covariance and validate args for whatever reason. Okay. Yeah, we sample from the thing. That distribution, sample, samples. All right. By the way, so that means that we'll have a print type. Not learning deep, just work with APIs. Companies are hiring these people, not ML expertise nowadays. Just learn software engineering plus AI. Oh, why? I want to learn the thing. Okay, so it's called actually. Why settle for the easy thing rather than like this way? This is interesting to learn. And W, and it is useful to also to already know it. To know it. Yeah. Okay, so log density, which is that thing. Okay, we have that view. Okay, this view thing is weird. Also, let's view Gaussian mixture, two-dimensional Gaussian mixture model, and its density and its density in the sample. Okay, it's a density and a sample. Wrapper around torch distributions mixture. Same family. Okay. This is a mixture of Gaussians, means, covariance, weights. Okay. Categorical weights. All right. Look probes. That view, stupid view thing. I don't know yet what it means. Okay. I can sample from it. Yeah, sample size. Okay, and I can get okay. And I have random 2D and symmetric 2D. Random 2D being take that seed, take these means, and scale them. Number of modes. Okay. Create tensor whose diagonals of certain 2D planes given by the M1 type 2. Okay. Focus towards health, education, research sector. Really, yeah, yeah. Yeah, sure. They are widely using APIs, but as I said, I want to learn the thing. It doesn't be not so much of doing more of research rather than yeah. And these things are not so hard to get, you know. Joining the industry. Well, I mean, it requires some effort, but it's not really something I'm saying myself. It's not my priority now, you know. It's something that I not interested in now, you know. So to facilitate creating patched diagonal matrices, 2D planes informed by the last 2 dimensions. Yeah, I'm still getting crazy with this dimensional thing. Yeah, I guess this one will be just diagonal matrix. 2 dimension 2D though. Okay, weights are ones. Okay, that means, and these weights, which is ones. Okay. And okay, this is for creating. These are factories for what are they called? Yeah, just initializers. Create this is symmetric 2D. We get here. In this case, this means. Okay. 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 That's random, and this is symmetric. Symmetric in the sense that it's a rotation. Or what? I don't think it's a rotation though. I don't think so. Maybe it is though, maybe it is. Okay. Densities, Gaussian, mean 0, covariance 0. This is the mixture. What is this? Yeah, okay, let's format this properly. This symmetric thing. Okay, and that's it. Okay, we have a quotient, we have a mixture, we have a symmetric mixture. Okay, the classic quotient, 2D quotient, is a random mixture, it's a symmetric mixture. Okay. Okay. What different means, and yeah, so this different means, but yeah, okay. And this we are, yeah, okay. If you want to build up your resume and get agentic pipelines, M loops. What is M loops? Loops. What is loops? Machine operations. Okay. Okay, this looks okay. Exercises. Align right. Okay. Why so? Why? Forecasting. Align from left to right. Single rule that explains everything. To combine two tensors element-wise. Vectors right justifies their shapes. What do you mean by right justifies their shapes? And that requires each aligned pair to be either equal or with one side equals to 1. Or missing. The result size per axis is the max. What? Int line 2 shapes up. And this concept is fine, but current job of corporate market is right race of using APIs. Yeah, maybe. Definitely. That can be practically true. Guess this thing is not teaching me exactly why that works. Oh my god, we're streaming 1 hour in. I don't feel quite well. I will go outside and come back. Okay? We'll do that. I will do that. Go outside and come back. Yeah. Oh, let's hustle. Let's keep going. Let me put some music to get my focusing. Yeah, makes sense. Makes sense. Yeah. Yeah. Which is broadcastable. Okay. Or theoretical. Yeah. Oh. What's that? One moment انك داير انك يا رجع against the machine شكل؟
Nothing
بس
pretty much is
ما
just...
سي.
Yeah, by the way, I'm sorry about the NSFW content I slid in there.
شت يا أخي. أقول إيش تيك ساعة أقول فاجئني الناس فرنسيين جاهم زمن خطيرين ما قد شفت قاعد.
I think the video is somewhere in a beach called Le Cap d'Agde. Le Cap d'Agde is a place where that kind of things is like legal. Like being publicly, even worse than that, like man, with your burn skin. En tout cas, les Français واضيين لهنا تكتب ذاك. Oh, يلا محمد رسول الله هنا. I sent it because vraiment I'm being serious. I heard some German in his accent. Does he have German roots?
هو عندنا أبوه جرماني طبعا هو اسمه جروتنديك عمر برمان.
Yeah, Grothendieck doesn't sound to me like a very French name, you know?
جاي أصلا من ستوري بداية حياته ريفيجي من ألمان أصلا.
Alexander Grothendieck, later Alexander Grothendieck in French, was he died 2014. Damn.
Yes.
He lived. He became the leading figure in the creation of algebraic geometry. His research extended to life used to be alive. Yeah, like Grothendieck was born in Berlin. Okay, makes a good amount of sense.
هو أصل ألماني.
Yeah, he's a German wanker and I...
كان آخر حياته عقب آخر حياته في وسط حياته بعد ما هو شو يقول هو عنه ما عنده جنسية لجته عنه يعد فرنسا عاد فرنسا قال ما عنده أي جنسية ما مش نسبية أرك هو فاوند يا شيء عندنا اسكو فاوندها والله Institut des études scientifiques. Grothendieck, a strong personality of Grothendieck was the board and the what? Strong personality of Alexander Grothendieck and the board sweep is revolutionizing theories were dominating feature at the 15 years of the IHS. Okay. Yeah, I think he wasn't. There is a story between. Yeah. Yeah, shit, nationality stateless. Adam Stone. Stateless. Okay. All broadcastable mean two arrays are broadcastable when their shapes can be aligned, expanding of size 1 by expanding dimensions of size 1. What the hell? That's a shape, and that shape. Broadcastable, yes. Broadcastable, yes. What? What? There's a broadcastable, no. Okay. Yes, no, okay, good. When you add them, NumPy conceptually expand the smaller array to match the larger one. It doesn't actually copy the values. It pretends the smaller array has been replicated. Okay.
Yo, the Rust.
No, هذا Python. هذا Python PyTorch library يعدل بها معادلات machine learning.
Replication mental model. When you add NumPy, conceptually expands the model. Low machine and diffusion models. Hang on.
From a broadcast operation, the residual array will have the same number of dimensions as the input array with the most dimensions. The size of each dimension in the resulting array will be the maximum size. Yeah, sure. If an input array is missing in a dimension, it is assumed to have the size of 1 in that dimension. Okay, so we try to match it. It will try to match it somehow. The dimension of this is just 3, 2, right? And this is 1, 2. Yeah, so it's just some kind of subsequent events. Let me try to do something. Try to play around with this. Up, UP, source, the thing, I buy it, and let's import a torch. You cannot do this, right? Yeah. It will expect the length of the first one. So dimension is just and the leftmost length applied that gives the dimension. And yeah, it's just an organization of the thing. That's a organization of the vector. I see. I'll get back in a moment. Should start it come back. I will be back in like say 30 minutes and I'll get back. Okay guys, we'll get back to you, and yeah. Coming back. Soon.
السلام عليكم. ترى عزيز تهون.
اوف اي مستر حوس سوا ماسي كنتون حتى كنت نقرا عنها وقت بايتورش كما تنسوراتي يؤدي سلامة بيا بتكنيك عندهم قاعدة برودكاستنج انتو عند السيد خيرت ميرسي ثانك يو مستر ايوش. What am I looking for now? Where is it? Yeah, there is. I don't. Yo, what's up, my man? شو ماشي؟
انا جيت انا قبيله ترجع ما خلص سكرين دبل لك كاتبه لي
yeah.
كومنت
Yeah,
قلت وانا اعتذر.
I see.
دوت
يس انا نزلت في حاجة لك مرة ماضية كنا واقفين عند بارت 3.
بارت 3
Yes, transforming distribution SDs.
تذكر لا سيميلاسيون للرواية اللي ما فيها دريفت والله فيها دريفت.
وقت ياها راكسة كانت ساعتين مرة ماضية شيء سبب خلاص شيء مكتوب. المرة الماضية بعد عدلنا سيميلاسيون هذا أورشتاين ألمبك هذول فيهم دريفت وفيه ديفيوجن في نفس الوقت. خالق اللي ما في دريفت برون موشن ما هي باردون ديفيوجن ما هي دريفت برون موشن واللي ما في دريفت إكواسيون لا سيجما مضروبة في دي دوت
زين في لا نويس
فيه لا نويز حق بعد وهذا يعقب يعود ريزلتاه فاهم تراجكتورات يعودوا ريزلتا ديستناسيون فينال يعقبوا يعودوا يكونوا نورمال ديستريبيوشن. شوف وصاد اللي فيه دريفت اللي كان لي سامبل منه هو موديل هو بروسيس أورشتاين أولمبيك وهذا الاختيار ويعقب يعود كمسا ذنبتو هذا الاختيار اللي أقوش له اللي أقوش ما فيه دريف ما فيه ديفيوجن ديترمينستيك ما فيه راندوم ما فيه نويز ما فيه راندومنس ما فيه ديفيوجن وهذا الاختيار صح هو اللي فيه ديفيوجن. وتشوف يديروا ديفيوجن نفس الشيء اللي لا ديروا ديفيوجن و 0.5 كوفيسيون 0.5 إلا كومسا يزيد ديفيوجن كوفيسيون يعود نفسه. That's it.
شو ذا انستغرام اللي ديترمينستيك لا واحد
متقادين كاملين مشاو كاملين قاسوا براوريتيهم كاملين متقادة بيهم اللي عاد حكم كيت بيجكسيون فهمت ما بعد فهمينالو عنهم
كذا اللي نطبق
ما فهم شيء أكيميلا ما فهم بوين وأكيميلا عليها وحدات أعرف كذا اللي راندومنس فهم بوينات وأكيميلا عليهم وحدات والله فهم انترفالات وأكيميلا عليهم وحدات يعني تعدلوا نورمال هم ما حسبوهم بوين ما حسبوهم اي والله حسبوهم بوين مو تراجكتورات عندك عددهم فين دونك تحسبهم بوين قالوا نورمال هم يحسبوهم كانترفالات عدد سبديفيسيون يحسب بروبورسيون كل واحدة ونتيا يطلع عنهم دنس حتى في الوسط بالتالي يخلق نورمال ديستريبيوشن فهم قاع نورمال ديستريبيوشن ما يمكن حتى تطلع له نورمال ديستريبيوشن تأباري حتى لينا نزيد كوفيسيون دريفت ديفيوجن برضو تو. والمرة الماضية كنا قريتين اكزاكتومون عند هذا عند هذا جرافاك هذا جرافاك تياه سيميلاسيون هاد ساعد هما what is it هي ليش فيكسي سيجماهات وديهات. هو من التالي هنا تيها تيوريم قالوا في ماتيا قالوا في الكل عن ديفيس عن ديستريبيوشن فينال اللي تعود هاي نورمال ديستريبيوشن فينال اللي يعود يتعود سنتري ويكارتيب سيجما كاريس دي تيتا. سيجما هنا تيها هو كوفيسيون ديفيوجن وتيتا هو كوفيسيون دريفت ليكواسيون اصلا. اوكي
هو شانج ديستريبيسيون لي نورماليزيها والله يسانطريها.
ديستريبيوشن فينال هو ما شانجي ديستريبيوشن هو والله بون هذا قد تقول عنه تراجكتوار هذا بروسيس كامل قد تقول عنه مازال قاعد هو اللي يناقش وقاعد في بارت 3 عن هذا الوقت عبارة عن انك تعدل ترانسفورماسيون ديستريبيوشن. كانت عندك مثال من ديستريبيوشن هنا تيا كل شيء متقاد يعني يونيفورم طبعا يونيفورم اكزاكتومون ابري لي ترانسفورماسيون ديستريبيوشن نورمال. انتو هذا اللي يعدل هذا اولمبيك ورشتاين اولمبيك. هنا هي إليستري رواية عن شتون في بشكل هذا الفيزياتياسيون كل سطر ده فيكس أركتها 3 دولين ديهم فيكس ريلاتسيون يا غير سيجما وتيتا ممسياني فهمتني. تقد فيكس دي وغير تفاري سيجما وتيتا تركي تعود عندهم نفس الدي نستعمل نفس الدي. اوكي اللي فري هم هنا تياها اللي راحوا عن الفيجر اللي جنرال بسياني نفس الشيء نفس البيهيفير يا غير اللي يخلق عن كونفرجنس يخلق بالعجلة. هذا ركتيها يخلق بالعجلة كيتوني تيها هنا تحت أبسيس يتراح عن سي 14 هذا كان طوله هذا كان يخلق في 14 في سي 14 قال هذا يخلق الليفت رولينج سانك. هنا تيها اللي زاد سيجما كي والله تيتا هما كاملين يزادوا بالأصل ياك
ما سيجما تيتا ملي
وي لا باش زادوا من لدو باش كونفرجنس خلق بالعجلة شور ديستريبيوشن تالي باش التراجكتورات اللي ارياتوار فيكساو على هاي ديستريبيوشن سي.
وبعد اخر شيء عدلته شنو؟
تو هذا وقت هذا اسمه اخر شيء عدلته اكزاكتومون هذا ونتيها في هذا بارت 3 مستقاع نقراه ركتيها فيه من تحت نقرا ذا كوتوشن هو وكنت ركتيها متبارك معاه ركتيها تحديدا بايتوش فيه نختار نعرف ونتيها جاء اسم روايات يعدلوهم كتابي ان سكويز وان سكويز في بايتوش في لابراري بايتوش ما نعرف اكزاكتومون اللي يعدلوا شنو هو و شوف يا خير ما سي بديت نفهم شي يعدلوا يا خير نمسي شوف من حيث شوف هاي سكويز شنو a lot of خلاص هذا functions شاد. كيف Okay. What? Ah. Okay. Okay. Alors attends, pourquoi square it? Why? How do you square it? Square every element wise. Okay. And then you sum them. Okay. Moving on. Where the car? Ah, yeah, sure. Sure. Okay. Okay, this makes sense. That makes sense. A break ball. يقبل يقلل distance. For some reason فهمت تروى كل تروى من جاي تروى جاي من wait a minute مش لا شنو randomly initialized attributes for exercise we use random initialized plus attributes although there are more sophisticated techniques such as the k-means plus method that can be used to improve the convergence of the algorithm. For the sake of simplicity we will stick with random initialization. Okay. Visualize randomly inserted centroids. Okay. Centroids are done. Assign the cluster to. Okay. What? What? This is not clicking to me. This is really not clicking to me. Should done some PyTorch sometime. Okay, we can continue, I guess. For now. Okay, he's too sampleable. Sampleable, yes. Oh, definitely need to learn PyTorch because next week I'm having yeah, the other implementation. And this one also contains implementation. Sample, but this is just from scratch thing. Samples, put sample, okay, we can sample that, we can sample that, we can sample that, sample whatever you want. Okay, two-dimensional Gaussian, set density, sample. I've seen this, mixture, and you have that. Implementing Dashboard Dynamics. In this section, we will simulate over the template Dashboard Dynamics. DXT is equals to. What's the issue, bro? What's the issue? I guess you can do it this way, right? You can do it that way. Right, yeah. Okay. We got the Dashboard Dynamics. DXT is equal to have sigma squared. The scoring of P, XT, DXT. Okay. Just some noise, some diffusion. Okay. This should represent what? I have sigma square. I have fill in the. Okay. Sure. Oh shit. Oh shit. I guess it's the. Set sigma. Okay, you have sigma. 1/2 times density of the density dot log density of x. Okay, and that's it. Okay, this is a float. It's fine. And this one, diffusion time is just sigma. now let's graph the results. Bit error out. Okay. And so simulator. We go with that. Stop that. That as is. Yeah, start with position arguments. Okay. You should. I don't know what. I have no idea what you end up doing. Contour must be increasing. What do you mean? Value error. Oh damn! It sounds like a crazy bug. Okay, wait a minute. Log one. Doing Ah, shit. Yeah, sure. True. Why that though? Why that triggered the actual mistake? The actual bug? Not sure. Okay, we're having here the finish off with a big mathematical exercise connecting the dynamics to understand with processes. Got that for suitably nice b measured and independent by for given delta sigma r. Okay, and okay, that's one thing. And this is the other one. We shall show that p of x equals to sigma square over 2 is the score given is given by okay. Okay. Can I accept that? Yeah, they are really helping as far as they can, as hard as they can. Okay, so this is simply taking the logarithm will give and then the gradient will eliminate the factor. The logarithm will get back that thing. And we'll get our x square, the square down, so we get exactly this thing times x. Okay, and thus we get back the we get back this process exactly. That yeah for this particular normal distribution. Okay, yo حمد ديك لباس comment ça va شماسي what's up. Okay, this is clear somehow somewhat. Okay, we have a big show here. This is Danjuan thing. Try for with value sigma, and then the number and range of simulation steps. This is the distribution, the target density. What do you see? What do you notice and why? ماسي حمد اكتب بس صحة حضرتك. What is the stream about? It's about doing this what is it again? Doing this course, Introduction to Flow Matching and Diffusion Models. I'm doing exactly this course. I'm reading this notebook, this lecture notes, and at the same time doing the labs. We have 3 labs, I think, or how many labs? Let me check the link again. عندهم 3 labs. Oh, come on. Is that كويسة? Yes, عندهم 3 labs. الأول working with ODs and SDs. Then flow matching, scoring. Third, diffusion, transformer, and VAEs. And that's it. That's pretty much it. This one, I don't need it. I don't need to get the hell out of here. I fixed my bug. Yeah. What are this lab thing? Yeah, lab لا هو اسمه جوبيتر نوت بوك. اوكي، هذا جوبيتر نوت بوك اللي هو الفاتح قاعد على نفسه، قال هذا فتح ماريما باردون. ماريمو عايد شبه هو شكلا عايد من الثاني تو نختار معنا مدي شكلا ماني فرق في الشكل هذا مش بيتنطبق وهذا توف براكتس ذا تريك ذا ثينك ذا دي بالكور انتو ان شاء الله يعد فيه building something from scratch به اللي يشبه من قد القراية بشكل عام. but yeah that's it that's pretty much it. لانجفان كنت نخلص لانجفان dynamics and apparently لانجفان فايتو عني عنك تمشي من عند يا let's see عندك target distribution. I know I was asking about the one you are using. What do you mean? It looks cool. ايه هذا ماريمو هو شكله زوين راي هذا. This is the future of Python. This book is here. في اسمنت هايب يا غير باو شكله زين ما بيشي الناس تبقى روايات بشكل نايس وشكل زين قال ما هو خفيف حتى مدي قال ولي سوا سي با مال okay, so what do we have here? Simulator. We have this solver of ODEs and we graph the dynamics starting from this thing, I guess. This simulator. Why we have a push here? And you seem nice. You are indeed nice. You are a kind person. نجوى. أصلك مريمة. دائما ستريم قبل بالتالي فترة عني قاع وقت الستريم يعود أنا نسي تعبان ماني لكن ربما شبهت من ستريم مع الصباح والله وقت ذاك والله ما وقت الساعة. استريح حمد استريح برو. So this thing, I guess, fluted evolution of samples from source under the simulation scheme. And under the simulation scheme, you have my simulator. Itself is a discretization of an audio SD. Okay, this is the number of samples. I found something. There is a big delay. Yeah. به اللي بيناتهم تقريبا 10 سكند. هذا لا يوتيوب قاحطينه اسمه هنا تلعب فيه سليب 10 سكند فاهم. and that sucks. That really sucks. بيلي تدخل 10 سكند علينا نشوف مساجات أقل مولي ميلي عاد شوف مما أنا اللي نديري له على شات لايف يعني شوف مساجة كلام توخا سي راك تكتب شي شنو تشوف انت تشوف سبيتش راك تعرف تكتب شي غير ما هكا. there is always small delay. Got this. Yeah. Wait, can't it be faster? Looks like not. See. هذا نديرو faster ريت ليتيميتيك فهمتني. I'm writing now. شات نوتيفيكيشن فوق هو 10 سكند غير قاعد تسمع اتوقع ديلي يا اخي يا اخي الديسكورد ما في ديلي. الديسكورد يتكلم فيه مباشرة، ما اقدر اتكلم في لايف. اوكي انا مني كنت distribution simulator density time steps pins show. The problem is YouTube. Yeah, the problem is from YouTube. واحدة عنا essentiellement واحدة عنا API ريت ليميتو ما قد تكمشي اسمها ريكوستات لو بين دالي 10 سكوند. اوكي so هذا اللي يقبل XRO distribution يباسي simulator trajectory every nth index. Where is every nth index? Okay, every nth index يترد n يعني يرد number of times steps. اوكي ديريكت كما اللي يجي رينج تاعته سينو اللي يعدل لي كونكاتينيتي دي شوز واحدة رينج فاهو ان الثانية اوكي ياه لا توفو لا نفس نو يا ثانية الإلمانت التالي دونك that's it. Okay. Is that right? That sounds right. And this to plot. أسيري عن تالية من ذات الوضع. Okay. Okay. بيبتدي time steps شيء من إيده من هذه XTS اللي يقبل من second أنا بس تنسرات ما افتكري ما أقدر أسبيت ما فايل بيبتدي على two plots أولاً دي يعدل دي بروتيب سكاتر بريس بروتيب هيدت sample size t equals same t t من Nigeria ناس t من okay yeah so it's plotting the same thing the KDE plot سكاتر عندي بوينات فرق KDE no سكاتر بوينات مع هذا
تأسيس
مرحبا حمد سوا
ناسي
ما شاء الله بس طريق
Do you know I have problem with my let's wait بس
ما سمعت شو تعال متأخر يوتيوب تأخر عني
اليوم
يوتيوب بالماضي ذاك تعرف حاضر
Do you know I have twins my pets twice? Yes.
راني سامع يوتيوب بس يا
Just that I have problem with Discord.
ما سمعتك.
Yeah.
محمد لو يوتيوب ده ماشي ونسيها متبري. يو وش يعني اوكي يا ده هو اكيد density عندنا هي عرفتها K density I don't know أنا قاعد نهكر اللي أنا أعرف شيء okay whatever yeah this is it هي تبارك معاي فرمي هو فرمي ومشى كم ساعة بديت عن الأمور راندوم تبدأ الأمور تكون very sure بتريك مثلا delivering the value of sigma and the value of the number and range of the simulation steps the source distribution and target density. What do you notice? Why? Okay, let me change. What the hell? A lot here. You can control the rugby here too. مش براك وش تو راب ولياك عيبة فينك كردوها كتير نفوت حدا نطلع حد فلما طلع لي انفورماسيون طلع فانكشن كونت سيجنتشر فانكشن اوكي هنا تيا هذه نشانجو سيجما في الانجوان باغ اكزومبل عندنا 1 شو عرفوش ياخدك بيسينا شغلات تشتغل خمسة تلك تمام قاسو شورا اللي مثل شي حرفيا تحت لا رد سقيرش من مثل very basic هو دي ما هو
I can't hear you.
ما اسمعك
Can you speak?
yeah sure you can speak
Okay,
Can't hear you.
I know. Yeah, I cannot hear it. It was a problem with the mic.
what do you mean?
Yeah, just the configuration. I was having a problem. By the way, are you now diving deep in machine learning?
Why you say why?
Yeah.
Because I think I want to continue my studies in it.
Why did you choose this topic?
That's what What's the question? Symmetry is not defined. What the hell? Huh?
What the fuck is going on?
أنا سامعك محمد.
Okay, I now can hear it. I was having some problems. This configuration, the sound, the drivers was broken. I was asking, why did you choose? Why did you choose this topic?
A topic. Did you talk about it? Yeah. This one, the one. Where? Okay. Which topic? Exactly.
Flow machine.
Flow matching.
In Diffusion.
Yeah. This algorithm is the one that is widely used now for image generation and video generation. See?
Oh.
Yes. When you see nano banana stable diffusion, whatever, etc., etc.
They are all working on the same concept, which is diffusion, but I didn't know of flow matching.
Flow matching is the new one. Flow matching, yeah.
Okay,
is-
I am outdated. So that
يا يشبه من diffusion وحدها. flow matching والله bon هو يشبه من diffusion. واللي هو flow matching.
are there any
Yeah.
can I say local models that use it? Because I have a project that is like somewhat in the state of the art. It use other local models
No.
to decompose the layer of the image. You give
ما
it,
نعرف
for
I don't know if there is a local model for that yet, but
I have it.
My
I
objective
built
here.
one.
well, my objective here is to understand themselves without not necessarily. This is also, of course, not necessarily the exact implementation used in practice. What I'm gonna learn here, but it's gonna be the general detail, the backbone detail, the fundamental detail behind him. See?
How did you go
Hmm?
already?
I am at chapter 3 now.
Chapter 3.
Yeah, before that
So-
it was simple. It just started. Wait. I'm coming back for the ماشي بدي أشرح جاي.
Yeah, okay.
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 Dinner break.
No problem.
استعجلت عن جينكم فليفر ليلة بعد شهر وشهر يجي بين حد من الخب تيك تاك ستايل صنع الخب شنو من يخرج شبه الجراكس عادة الأمور سيتم شبه ستايل
زين والله يعني تعال بي أقول صبغت حسب ما هم طول الكاسين أنا عبد الرحمن شي مكتوب في مكتوب أنتو ده problem ليك تدي ليك problem لك بس أنت لا تلاقي ما في الغالب دور اللي أتوفي أو دور اللي يشوفها متى يشوفها عنهم المستشفى مستعجل غير هم بدأ أقول عنه كان يصير والله دعم أقول صبر حسب ما كل الكاسين أنا أدرك ماشي ممكن في مقطوع أنا وأنت ده problem لذيك
I am back. Hello. If there is anyone still here. Okay, let's film. Okay. Okay. What is the issue here? This wasn't it. This has errors. What errors? What errors? Errors. Syntax error position. D'accord. Pas de souci. Pas de souci. Les dates justement. Ok. Ok. What the heady? Okay, the animate. Yeah, okay, nice. Nice.
هاي يا أخي
Hello.
واصل.
ما شاء الله. بس شو مست mirror simulator أنا سراي. أنا لهذا الكود سوا. Okay, management dynamics is the thing moving when
So-
distribution is to another
الحين انك تسوي
way.
انك قص ديفيوجن فلو ماتشنج عنه هو نسخة جديدة من ديفيوجن.
هو the new state of the art algorithm. بس ما بتعرف تراعي اللي هو اللي نقراوات يعني عارفين اللي نقراوات يعني. اللي الحين نشوف the animation شو تعدل. We discovered what information is about. والله بس قاعد go ahead. بدي عندي نفس. Nice animation. Okay, so this is the thing. Okay. الآن شو فايتوا عنه يكونفرجي لك القضية شهر. Okay, that makes sense. Okay, diffusion information هذا هو. In the previous work we constructed أنا شايف كثير كامل مالي. يصير تاري مهمين. سؤال فخبار تشانجي سيجما target density سيجما حاجة دي شني normal سيجما وي سيجما interesting شانجية بيهلي يا اوكي good في matching RI. In the previous section we constructed the flow and diffusion models as generative models parameterized by a neural network vector field u, t, sigma, theta. However, we have not discussed how to train them, i.e. how to optimize the parameters theta such that generative model returns something sensible, i.e. a nice looking image or exciting video. Next, we discussed flow matching, an algorithm to train u, t, theta that is simple, scalable, and represent the current state of the art. Oh yeah, flow matching لا algorithm training. diffusion مو اسمهم
بعدين
كان وش يسمون؟
نفس البرنسبل اللي ماشي عليه ديفيوجن.
يس نفس البرنسيب يا خير. الالجوريثم اللي تريننج هو
خلاص.
اللي يشانج عاد هذا فلو ماتشي. That's it. apparemment
زين
as far as I
قلت كماس
understand.
اللي عمل كماس من نويز جنريت عقب. اوكي.
In this section we restrict ourselves to flow models, i.e. we have a neural network U T theta and obtain samples from the generative model by simulating the OD. X0 samples from initial probability, and we have this dynamic which is a flow model. Okay, and using totally deterministic, of course, and using the endpoints x1 for t equals 1 as samples. Wait a minute. As we discussed, the goal is that x1 is distributed according to the data distribution p data. Okay. Therefore, the question how to train a neural network is really the following question: how to optimize data such that simulating the flow in equation 10 results in samples from the distribution x1. Okay. Figure 4. Gradual interpolation from noise to data via Gaussian conditional probability path for a collection of images. Note that each image is a data point of dimension t 2 times 32. So we are plotting individual samples from the probability path. While in figure 5, we plot the distribution as 2D histogram. Figure 5 message. Conditional and marginal probability path. The first step of flow matching is to specify a probability path. Intuitively, a probability path specifies a beautiful interpolation between the noise p init and the p data. But why would we want that? Remember that our desired ODE fulfills x0 follows p init at t equals to 0 and x1 follows p data at t equals to 1. But what about in between? It turns out that we have some freedom of choosing what will happen in between, and this is what is mathematically formalized in a probability path. In the following data point x, c in RD, we denote for a data point z, we denote delta z the Dirac delta distribution. This is the simplest distribution one can imagine. Okay. Sampling from x delta z always return z, i.e. deterministic. A conditional interpolating probability path is a set of distributions p t x's such that c over rt such that p0 of c is actually the initial distribution and p1 is actually the delta distribution, the Dirac delta. Okay, at c. In other words, a conditional okay BD. Yeah, تقدر deterministic confirm. No, هذا lateral path بيناتهم هنا. A conditional path between the unit and the Dirac mass. هم حق عنهم ليعدلوا يقبضوا data اللي initial وما عندهم initial points من هذه distribution فينا البي داتا عندك منها اللي اكزامبلات فيني هي داتا ستك حرفيا معناك probably what they will do is just that they will make a combination of direct masses on these priorities. Maybe not. In other words, conditional probability path gradually converts the initial distribution into a single data point. You can think of priority path as a trajectory in the space of distributions. Okay. We have here, it's collapsing into one point, and we have here, it's marginal. You have not seen what a marginal mean. Every conditional path induces a marginal probability path PTX as defined as a distribution that you obtain by first sampling a data point from P data from the data distribution and then sampling from PT such that Z, okay, conditioned on Z. Z is sampled from P data, X sampled from PTZ implies X follows PT. Sampling from a marginal path.
What does P data here represent?
P data.
What does it represent here?
P data represents everywhere here. The hypothetical distribution that of the data set, and you have a data set, and you are supposing here that this data set, the data set is finite. Always, it will be always finite. But you are supposing that there is a distribution on the data set.
Bounded. That set can be bounded, but finite is not obligatory. You can have bounded data, maybe not finite. Do you understand?
Your collected data, you're storing it somewhere, so it will be always finite.
You can store it, but you can have all the aspects between the data and all its variants. You can store for example, you can store
maybe
1 and 2, but you have all the subjects set from the data between them. So
true. Okay, that's a valid case. But probably in the end you will just pick a finite set of that to train your algorithm.
Yeah.
Okay, and to train the algorithm, you are here in this case you are supposing that the data that you are training on or using has a distribution.
Yeah, of course.
And what you are doing is trying to create that distribution to sample from. See, you try to construct that distribution so you can sample from it to generate new images. Sampling is exactly generating new examples, new information or generation. In general, it's just sampling from this data. Is that clear? Is that understandable?
I didn't hear you. Your voice got cut.
What I said is that generation. What we are doing here is simply is creating generative models that generate new data. Okay. Now, sampling from P data, sampling, you have a distribution, so we can sample from it. Sample means just taking an element randomly from the distribution. Okay. That is equivalent of generating a new value. Okay, when you construct a probability for the density, you actually have access to, you can sample from it, and by sampling from it, you take a new element, new data points that weren't in the initial data set. Okay.
So that is what we represent p data.
Yeah, that's what p data represents. This maybe better said here
So it's
than what I said. Yeah, this is generation. This is exactly what I said. When you look at this, yeah, this generation is a task. Generation is the task of generating samples from the probability distribution p data, having access to a data set of samples z1 to zn, following p data during training. You have a finite points from following this distribution, probability distribution, and then taking a sample from this distribution. You want to reconstruct this distribution. You have just finite elements from it. Okay. عندك لا عدد فيني منها. تريد reconstruct هي كاملة. Okay.
Yeah. Okay.
Yeah, that's it.
I see the text.
Okay. The density of marginal path. This is why this is the case. You are here, is integrating the thing to two parts.
Such as image video.
Note that we know how to sample from PT, but we don't know the values ptx as the integral is intractable. We can actually compute equation 12, but not equation 13. Check for yourself that because of the conditions of PTZ in equation 11, the marginal probability path PT interpolates between P init and P data. The by far most important example of probability path is the Gaussian probability path. Hence, we strongly recommend reading the next example thoroughly. Okay, let's see about this one. This is still not so clear to me, but gonna see.
Every condition probability path PT include a margin probability path PTX defined as the distribution that we obtain by sample from the data distribution and then sampling from B to Z. Is the equivalent of ZBT. Sampling from the marginal path, destiny of marginal path. That we know how to sample from PT, but we do not know destiny value PTX. Compute equation 2 but not equation 13. Let's ask yourself, check for yourself that because of the condition on the PT in equation 11, where is equation 11?
Yeah, yes, there is a lot of some clear math here, but they are not clarifying it so much.
Yeah,
I guess
somewhat makes some sense. The note that they can sample from PT but not check the destiny of PTX. It can
Yeah,
It's
I
kind of
can.
mess.
Yeah, I
Yeah,
can.
it's kind of mess.
Yeah, I can accept it. Yeah, that's okay. But it's just that it's not so
Yeah,
clear
kind
yet.
of mess.
Let's see what the example. One particularly popular priority path is the quotient priority path. This is the priority path used in most state-of-the-art models. Let alpha t beta t be not schedulers, two continuously differentiable monotonic functions with alpha 0 and beta 1 equals to 0, alpha 1 beta 0 equals to 1. Then we then define the conditional path, priority path, being pt such that c equals to alpha 1 c beta squared identity. Okay.
Does identity here mean?
Huh?
What are they representing?
Hmm?
Identity.
Identity matrix. Square identity matrix.
Yeah, yeah. Yeah, I know, but what is the purpose of it here?
This is a normal distribution with a mean being this and a variance being
I know
beta
that.
squared.
I know the normal distribution is على percent circuit. So
Yes,
That is a normal.
but, yeah, this one is for that's when yeah, they are the same thing. This is just for n-dimensional normal distribution.
Okay. Yeah, okay. All right.
Which by conditions we which by the conditions we imposed on alpha t and beta t for first p0 of condition on c is equals to the normal distribution of 0 c beta squared g, which is the standard normal distribution centered and with standard deviation 1 or identity covariance matrix, and p1 for wait a minute, p1 of conditioned on c is equal to normal distribution with mean alpha 1, okay, and variance 0, more variance standard deviation being 0, which gives exactly the Dirac mass. Okay, but this is still unclear. Let's just continue. Because I'm not sure yet why they are insisting on Dirac masses, but let's go on. Where we used the fact that the normal distribution with zero variance and the mean c is just the Dirac mass. Therefore, this choice of xz fulfills the equation 11 for p in it equal to the normal distribution, and is therefore a valid conditional interpolating path. In figure 4, we illustrate its application to an image. We can express sampling from the marginal path pt as z sampled from p data, epsilon sampled from p init, which is the normal distribution, and x equals to alpha t z plus beta t epsilon sampling from the marginal conditional path. Intuitively, the above procedure adds more noise for lower t until time equals to 0, at which point there is only noise. In figure 5, we plot the example of such interpolating path. Okay, figure 5 is
Seem
missing.
like the most
Hmm?
seem like the most important equation the most important equation in conditional and margin probability path is the 11 equation. It seems like it is the base.
This one. Yeah. And the reason why it is the case, it's linked to this one, I'm guessing, but it's still not so clear. Okay, maybe. You know, you want to train the model to predict, to sample a certain z from this denoising procedure. Okay, so what you do actually, you want a certain smooth path from the normal distribution into the Dirac mass. See what I mean?
Like couple seconds, I'm just following the page. In which page you are?
15.
Okay.
What
did you say?
Okay, what I just said is that I'm trying to make sense of this equation 11, as you said. So what I'm understanding now from it, yeah, go on.
Did you get the graph or the example that they are giving of marginal and conditional when they start of a noise of t equals 0? For conditional, it says that it die or it condenses to a star, and for marginal,
it will, because the Dirac mass is simply a distribution where it is equal to 1 at z and 0 elsewhere. Okay, Dirac mass of x is equal to 1 at z when x is equals to z, and 0 elsewhere. So it's a mass distribution. It's deterministic, as they said. There is no randomness in it. It's one thing.
I didn't read it fully, but from the same noise we should have almost most of the time the same result.
From them?
From the same noise,
yeah,
we should at least most of the time have the same result or something close of it, because it is not fully random. But I see here the marginal and conditional have different results. I don't know why I didn't read it full. I just looked at the diagram.
Yeah, marginal is something else. The conditional that they were talking about here is simply is the path from a Gaussian distribution, from a p-init, or not a Gaussian, just any random distribution, into a Dirac mass. As I said, the Dirac mass is just it's deterministic. It's a distribution where only one choice is possible. Okay, it's equals to 1 at z and 0 elsewhere. Unlike any other regular distributions where you have values of possibilities in many places. Anyways,
okay.
So what they are trying to do here is simply, since that you take a point that you want to train your model on, okay, from your data set, and you train your model. Your training step will be just training the model to predict that point from randomness, from the normal, from the p-init, which is the normal distribution. Okay. And there is what they mentioned here is that there is a nice smooth path of densities between between the normal distribution and the Dirac mass. Dirac mass is the deterministic thing that you are sure it is this, and normal distribution is it's a normal thing. It's a natural thing to have as random. Okay. So what's left to determine is actually these alphas and betas. The conditions on alphas and betas are very natural, that they are continuously differentiable. They also monotonic for some reason, however, and they satisfy some initial conditions or boundary conditions from at 0 and at 1. And that's it. So this probably makes sense a bit. Makes a bit sense. Okay. Intuitively, the above procedure adds more noise for lower t until time equals to t0. Until time t equal to 0, at which there is only noise. In figure 5 we plot an example of such interpolating path. Okay, we'll see that later. Anyway, I wanted to check something. Figure 5, this is the figure 5. Resolution of a conditional top and marginal bottom path. Here we plot a Gaussian probability path. Alpha is equal to t, beta equals to -1 minus t. The conditional path interprets a Gaussian p-net to in the p data, which is a direct mass for a single point c. The marginal path interpolates a Gaussian in the data distribution p data. Here, p data is a toy distribution of dimension d equals to 2, representing a chessboard pattern. Yeah, okay. This second thing is the marginal distribution.
Marginalization trick. Give you conditional vector field. Vector field which target defined as one of the marginal property path. Alright. For this design might be say convert noise into data. To the start of the book.
Okay, so conditional path, conditional marginal vector fields. A priority path specifies what distributions xt following pt the point xt along a trajectory should have. What distributions the points xt along a trajectory should have. At this point, this is what we wish to be the case. But how we can find a vector field such that trajectories xt follow the priority path. Flow matching explicitly constructs such vector field, the marginal vector field, which we explain in this section. For a data point z in RD, let ut target denote a conditional vector field. This can be any vector field, such that the corresponding ODE yields the conditional path priority path PT condition to NC, i.e. such that it holds x0 following p unit and differentiating xt. Yeah, xt is a flow. Okay. Which implies that xt follows pt. Implies okay. xt being a flow implies that xt follows pt. We can often find a conditioned vector field UT targets analytically by hand, i.e. by just doing some algebra ourselves. We illustrate this by deriving a conditional vector field UT xt conditioned on C for our running example of a Gaussian priority path in example set.
This visualization from to data is facilitated by simulating of ordinary mode.
At first sight, a conditional vector field seems useless because all endpoints of the ODE expand will collapse to C, i.e. we are just regenerating unknown data point C. However, the conditional vector field serves as a building block for a vector field that generates actual samples from the P data. Marginalization tree. Let UT be a conditional vector field. This specifies this thing. Set a marginal vector field UT target X defined as that thing.
What does the state of the art image in art machine behind seeing widely applicable? We believe that the theory behind flow and diffusion model is elegant in
follows the marginal priority marginal path.
This course will be a lot of fun for additional resource by selecting what are self-contained. There are two additional resources to use. Lecture recording a guide to section in this lecture. Allow this guide an example to diffusion model from search with single code. You can find this on your
Particular expression. Particular x1 follows in flowing p data for this OD. So that you might say you see target converts the noise into data. What 0 minutes?
Based on the telepathic supplements published for the season include a brief section of section 8. Don't worry if some of the concepts are unfamiliar. Generative modeling as simple. Let's begin thinking about various data types or data mobility that we might encounter and we will go about presenting a numerically image. Consider image with each pixel which height and width. The mesh is to say color review for all pixels in every color. Shown we are given an intensity value and therefore image can be replaced by an LMR said okay. I'm getting up to the date. Video is simplicity of time. Image in time if t as in point of frame the represent element by th. Okay. I am getting up to time. Molecular
Okay.
structure in life way would be to represent the structure of matter. Atom in the matter in each set is described the location of the atom. Of course, there are atom more sophisticated to a different structure molecule. All above are an example the object that we want to originate can be mathematically represented as a factor. Will potentially often flattering, therefore for our stock we will have key idea. We identify object being generated as factors that okay, that is useful. A notable expectation to this above is text data, which is typically modeled as a direct object by large language such as GPT. While continuous data is okay, the data is continuous. While continuous data set is our main focus, we also study text generation in section. So the data is continuous. The data that we are working with is continuous. Generation as sample it as find what is mean to generate something. For example, let's say we want.
It doesn't need to be. It can't be. You're just taking it as a hypothesis. It's just an assumption.
Well, they say that they themselves say that a notable exception to this above is the text data, which is typically modeled as descriptive object by language model, while continuous data that appartient à RD is our main focus. We also study text generation, so their main focus is continuous data set in RD.
Yeah.
I just got to the start to be
Nice.
up to date.
Oh, yes, it's cool.
Yes, let's move on to generate image of dog. Naturally, there are many possible images of dogs that we would have used, and but there is no one single best image of dog. Rather, it is a spectrum of images that feels better or worse. In machine learning, if it is come to raise is the diversity of possible images as a probability distribution over the space of image. We call such distribution a data distribution, okay, and denote it as p data. Okay, that is good.
White P data.
I found I found the meaning of it. It can to rise the diversity of possible images as probability distribution over the space.
Illustration of theorem 9, simulating probability path with ODEs, data distribution P data in the background. Okay, yeah, this is okay. Gaussian PNet in the background, and top row conditional path, priority path. Left ground truth samples from the conditional path, middle ODEs samples over time, right trajectories over bathymetric ODE with ET target in equation 20. Bottom row simulating marginal probability path. Yeah. As one, I guess marginal is just an aggregation of conditionals. As far as I understand it now. As one can see, the conditional vector field follows the conditional probability path in the marginal vector flow. Vector field follows the marginal probability path. Okay. Example 10. Big fat example. As before, PT following C equals to being the normal distribution seen before for noise schedules alpha t and beta t. Let alpha dot beta differential. The derivative with respect to t to alpha and b dot b so as well, or beta. Denote respective of k term derivatives. Here we want to show that the conditional quotient vector field defined by this thing alpha dot minus beta dot over beta alpha z plus this coefficient, okay, is a valid conditional vector field model in the sense of term 9. Its ODE trajectories satisfy xt is following the normal distribution seen before. If x0 is following the centered normal distribution. In figure 6, we confirm this visually by comparing samples from the conditional priority path grounded with samples from simulated ODE trajectories of this flow. As you can see, the distribution match. Damn, okay. These two things match and they are completely coming from different things. Okay, the proof. Let us reconstruct the conditional flow psi first by defining psi that xt is the ODE trajectory of psi and x0 following planets, which is a normal distribution, and then by definition xt will be psi target x0z, which is this other thing, We conclude that these trajectories are distributed like conditional priority path. To extract the vector field ut and society by definition of a flow. Okay. Okay, it's a reparameterization thing. See figure 6. By the way, when do we hit chapter 4?
They say they have a course or some kind of material.
Sorry?
Didn't they say they have a course or a lecture recording?
Yeah, they have it. They
Did you
have
look at
it. Huh?
You looked at it or no?
I looked at the first one. It wasn't that the text is better. Its text is more, it's better, it's shorter. However, it's
it's missing some stuff, or kind of confusing. It's missing some stuff, or
no, I don't think it's missing that much stuff. It's just that maybe the priority background in it. Me myself, I need to back up my. I need to refresh my. Huh?
Same, or even worse than you. My priority background is getting bad, really bad.
Yeah, I wanted to. Yeah, for that reason, I wanted to. What is that book? Richter wrote. Yeah, this book is a free book. It's online. Maybe I will check it. It's really good. Yeah, but maybe I think of doing it on streams actually, because it's not that long, and I need to, start this 100 something is fine. Otherwise, there is another also book, Stochastic by Alexander. This one is good also. It's online also for free.
Yeah, I'm working now at a model for.
But this actually this is about stochastic processes. Stochastic processes, I don't think you do that in before masters. It's it contains this you will see it really quickly. Brownian motion. The stochastic differential equations, which will appear here. These kind of equations. But it's not a big deal. It's just that one needs to.
What is
the
building for it? What is useful for it? What is the use?
Yeah, it's a differential equation, but it's a stochastic one. You have something called a Brownian motion here. It's very important also concept. You may have read that in the introduction, that the tools used here of stochastic differential equations are versatile. They are used in many other places, like in finance and whatever. This is the Brownian motion.
I have heard of it. Not really dive deep on it, but I have heard of it.
Okay, cool. So this is it. You need that thing and to construct the Brownian motion, or to construct, the stochastic differential equations toolkit, you need something called Ito integrals. Ito integrals is this first part is just the introduction, just some talking, 4 pages. And then you have you go quickly into this book is quick. It goes quickly from priority space to random variables to stochastic processes, and then to Brownian motion, and then Ito integrals. And from Ito integrals, you can define stochastic differential equations, like precisely define them. This is like some 72 pages of reading. But it's definitely worth it. I'm thinking of even doing it on stream, but I will try to do it off stream to be more efficient. Yeah, so that's the part that's needed, stochastic differential equations. And you have the part about probability. The way they constructed this construction here, constructing PT from marginals, from conditionals. From conditionals. This is, I think, it's a pretty standard way of doing it. I think it's the standard way of constructing PT of X from PT such that Z. You just sum over all Z with weights coming from coming from the actual distribution. It's a weighted sum. This integral is precisely a weighted sum. See what I mean? It's on some point area. So yeah, because the integral is a sum itself. See what I mean?
It reminds me of research that I'm now. I did say that it reminds me of research I'm doing right now. It is
cool.
for some banks. It's mostly liveness detection and face matching using a front camera and non-proprietary model or anything.
Cool.
Have any idea about it? Any help? We can use it all.
Um,
I
we can discuss
I read
about it
some-
more if you like,
I read
for sure. If you don't, if this is
What?
going on
Can
YouTube,
you-
by the way, so you can.
Oh, this is confidential information. Okay.
Yeah. Yeah, well, it's up to you, but we can. I prefer it also to discuss it off stream, since or if it's related to this, we can talk about it. Yeah.
It is not related 100%. It is all in the vision and the matching.
I see.
Fortunately, I have.
So you do
another
something
model.
like cosine similarity or something like that.
It's mostly we find the person. Is it a real person or a fake or a photo? Is
Ah,
a person match person in the photo of Hal Madaniya and something like that? We detect, give it a score, some stuff like that.
I see.
But I have another model which is closer to this. It is a diffusion model that take poster or image and decompose it to layers. Like when you give it a poster that have pizza, hand holding a pizza with text,
I
and
see.
behind it them kind of decompose to layer. The pizza alone, the hand, the
I see.
text, it all in the composite and generative the missing pieces. This is a model that I'm working on right now. I'm speaking with you. I'm working on it. So
That's cool.
yeah.
That's cool.
Lecture to detect the Arabic letter, because in most poster they don't not use how can I say it? The default font for Arabic. You have some
Uh,
font like Ufi, some Ramadan Kareem that is like I don't know what
Okay.
flower or something. So you should be able to detect it as text and reproduce it.
I see. That's cool.
Yeah.
Cool stuff.
It's,
Okay, so let's continue with this. See what's let's try to finish this and attack lab 2. My goal here is to really reach the lab 2 tonight, at least, because yeah, so that we can go forward really quickly. I'm getting the sense that this is not going to be a super
Easy.
practical. No,
Yeah. I found it. I saw that. I think it's kind of more heavy on the theory.
no. Even the practice here, these simulations are not so much like from scratch, or I'm not actually building something. I'm just answering some basic questions. Yeah, until now. I hope they are more involved. They require more effort. Otherwise, it's
So, speaking about the collab,
mhm.
I am in it now, and I see it is mostly they have wrote all the code almost. Take 1 semester to happen.
Yeah, that's not fun.
Maybe they have some exercise or not. Do they?
They should have. They should have. They contain exercises, but the thing is, I need to build stuff from actually zero. But well, maybe I don't need to. I don't know. I will see. Okay, Marima is back.
Pen testing stream. I didn't see you do any of them. They might be. Cool.
Yes, I'm more now into the machine learning things. But probably maybe I will do some cybersecurity things. I don't know.
You think
Mm.
it is more fun for you now to go deep on?
Well, I'm more interested in it because I will do, as I said, I will do the rest of my studies in this.
Machine learning.
Yes, the more of the mathematics part instead of the
Yeah. Like your paper art says.
my
Like your master paper.
yeah, you've seen it.
Same idea.
Yeah, almost. Well, hopefully better.
Yeah. What the same idea of explaining machine
Yeah,
learning.
exactly. Using tools from mathematics to attack machine learning questions.
Are there a field like this?
Yes, there are many people that do
Not
similar
people,
stuff.
I'm speaking about field, academic field.
Well, not so sure. But there is, well, when we're talking about field in the research level, the question is actually, are there lines of research in this area or in this, are there people that actually work on these kind of things? And the answer is yes, there are many fields, many research projects on this. Many people work on these kind of things. But until now, there is no really something something that is crazy big happened. It's still very not so impressive. But however, we can't know. The thing about research, you just have to move forward. You cannot know if what you are doing is what are the implications of your work. You need just to move forward on what you're doing.
You find your field. Don't follow field. In research, you don't follow field.
Yeah.
To find them.
Yeah, sure.
I was thinking that you have taken your master, because I was thinking of it as in the eye of someone trying to do master.
Sorry?
I was thinking of it as someone trying to do
which is? Do you copy? Sorry, do you hear me? What did you say? I didn't.
Where did you land on your doctorate?
Not yet. I'm still looking. I'm still searching for stuff. So this is lab 2. Lab 2. Hopefully it's better.
How about teaching?
Huh?
How about teaching, or you don't like it?
Teaching exactly what and where?
At the uni.
Well, when I cannot teach now, actually. This is the summer, and I hope I get my doctorate by the beginning of the coming year. I start working on it, so I might not have an option for even teaching here. See?
You are not looking for Dr. I'm waiting.
Hell no. No, not looking for it here. I hope I don't get it here, inshallah.
مغربي عربي.
Huh? No,
المغربي العربي.
no, I'm trying to get some, to get one in Europe. Something that is at the edge of, at the edge of research, you know.
سويسرا.
Yeah, something like that. Something that direction.
اللي عساك من فرنسا.
Matter.
France. I don't like it. I should like it. Not up to.
Yeah, the right to not like.
Not up to the standard, or it is not.
No, ثم في IHS Institut Supérieur des Études Scientifiques. فيه ياسم من موريتانيا ومتيالي عندهم big labs, big stuff.
Might be me. I don't like the. I also don't like the French language, so it might be like.
Why?
Yeah.
Why so?
I just hate it.
Just eating is not wise. Okay, this lab is actually not so bad.
Not so bad.
Not so bad. Lab 2 is fine. It contains a lot of things. And that's interesting. Okay, so what did I stop? How long was this thing till now? 5 hours. I think I will stop here. Because it's already 5 hours and it's already late here. I will continue this next time, inshallah. I stopped here at continuity equation.
Okay.
So this is actually not so bad. And at the same time I'll try to refresh my probability and stochastic differential equations background. And yeah, inshallah. Okay, thanks Hamad for coming. Good to see you here. Thanks to viewers on the channel now, and يعطيك سعيدة حمد.